part of the session today is going to talk about how we encode memory and what is what we call mental representation. So we are going to talk about these aspects of memory. First of all, when we are experiencing an episode with a specific kind of things that are related to memory. So let's say the first time that you can kind of drink coffee or you start to drink coffee. I'm not sure if Adrian is online right now, because Adrian was talking about the kind of experiencing of not kind of drinking coffee when they are, she was younger. When was your first experience of drinking coffee, and how is kind of your, let's say, family or kind of community role, kind of rules in terms of when, kids could start to drink coffee?
Honestly, I don't remember the very first time when I was drinking coffee. I think it was at home. I was trying my parents' coffee, but so it was not like forbidden or something, but we just were like 15 or 16 and we didn't want to drink it, but we wanted to be like adults.
Okay.
So that's why we went to like different coffee houses. But I think I started drinking coffee when I was 25, so quite late.
So when we have a specific kind of experience as kind of drinking coffee in a specific place or in a specific kind of condition, so you when you are experiencing an episode in a specific, let's say, as we discussed, when, where, with whom, or those types of kind of, let's say, questions, you start to basically process different aspects of things that are related to coffee. So it's visual aspects, it tastes, different visual elements that we have, and we discussed about those processes before in terms of, let's say, where, what pathways in the visual system, and then we discussed about multimodal conceptual representation of these topics in different parts of the temporal cortex. So we know that these parts could be processed and then being something like represented in a map. So they can make a representational space in different parts of the brain. And then when we start to recall that specific episode, we start to kind of remake that specific experience that we had. The interesting part is that when we discuss about experiencing an episode, and if it is the brain, let's say when we kind of see a cup of coffee, we have activations in the visual cortex and activations in some other aspects of the kind of the brain. So we have activation in different parts of the brain. When we want to kind of reshape or remake that specific memory or recall that memory, we should have close activations in the brain that is going to kind of reshape that specific memory to remake that memory for us. So when we do experiencing or when we do recall, we have similar brain activations. So we basically make a specific, let's say, representational map from the concept of coffee in our brain, and then when we want to re-experience that episode, we just activate those representational maps, and then they would be able to make that cup of coffee again for us, and we start to imagine. So then our kind of re-experiencing could be as clear, even to a really good extent, compared to what we have been experiencing before. And how this is happening in different parts of the brain. If you want to kind of go to the more details about how this is happening, when we talk about a specific, let's say, cortical representation, when we talk about the information that is being represented in cortex in a specific pattern of different modules that are activated in the cortex, okay? This is how we basically perceive an episode. So when we perceive, we have this activation map. This activation map would be also connected to a kind of smaller representational map in the hippocampus. We have the representational map of that specific episode that we have been experiencing in the cortex, but we also have a sort of a smaller representational map in the hippocampus as well, okay? And we make these type of connections in the hippocampus as well. But the difference between what we have in neocortex and hippocampus is that those pieces or those elements of that representational map would be connected to each other as well in hippocampus. But this is not going to happen in cortex, because in the cortex we have a really larger map, and this map is composed from different parts, so they are not well connected to each other. But the connection would be happening in the level of hippocampus. So hippocampus basically connect those pieces together. So we have the connection of those pieces together in the hippocampus, okay? And then when we recall something, most of the time the recall is just being exposed to a part of that episode, not the entire episode, just having some, let's say, just having some cues. Those cues would activate a part of that neocortical map. That map would activate the part in the hippocampus, and then hippocampus would connect them to other kind of dots of that representational map in hippocampus, and then they would activate other parts of neocortex that are related to this, let's say, cue. So we start from cue, but at the end we have a full experience. So we have a full activation of the entire map that we had in the cortex. And this is the way that we collect information in the brain, or we basically record information in the brain. So we perceive things in our cortex. We have a cortical representation of the episode that we experienced, the full episode that we experienced, the full event that was happening outside of the kind of our brain. We have a representation of that event in different parts of the cortex. These parts of the cortex would be related to hippocampus, and in the hippocampus, so we have a cortical representation in the brain, mainly in the cortex, of the episode that we have been experiencing. That representational space would be connected to a smaller map or a smaller representation or a smaller memory in the hippocampus. And those pieces in hippocampus would be connected to each other, but they are not connected in the cortex. And then when we have in the process of recall, when we give people just cues, let's say asking about, this could be, let's say, a birthday party 5 years ago. And then when somebody asks you about, okay, what was the specific, let's say, event that has happened there, or specific things what that specific friend was talking about at that party, those cues might be able to help you to activate that kind of smaller representation in hippocampus. And because these pieces are connected to each other in hippocampus, then other cortical parts could get activated. And when you have the entire cortical map of that specific episode being activated in the neocortex, you would start to re-experience that episode again with its full details. So that is the kind of a really simplified way of explaining how cortex and hippocampus are interacting with each other to record an episode of memory and then reactivating that in the future. Meanwhile, I should say that, as I told you, there are always some episodic memories or different events that are basically connected to each other. Over the time, it seems that when we make episodic memories, over the times we start to get from, let's say, events to facts, or they could just be beliefs. So they might not be always facts, but they could be just beliefs that we have, or the kind of perceived facts, whatever we are perceiving from outside. So we can go from, let's say, specific events to providing specific facts. For example, this, let's say, guy, based on the kind of the experience that we have with this guy, we can go and say, okay, this guy is doing this, loves this, doing golf. So there are specific features about this guy. And when we kind of have a cue, we can have both semantic memories and episodic memories being activated. So that is exactly the same as what I was discussing with you in terms of that piece of, let's say, cake or let's say chocolate cake. When we have been discussing about that, we have been saying that, okay, we have some activation of episodic memories, and also over time we have activation of specific semantic memories. And this piece of cake could act as a cue to bring all those memories up about even things about, let's say, the importance of, let's say, chocolate in your health, the kind of the role of sugar, the negative role of the fat that we have in the cake, the taste that you might have from it. So all those kind of semantic concepts that are related to that specific cake could get activated as well. So we know that these things are going to be connected to each other. But it might also be interesting that when we talk about, let's say, episodic and semantics, those semantic parts, it seems that are more related to neocortical or cortical parts. But when we talk episodic memories, they are more related to the hippocampal part. And to say that when we have, let's say, an error in the hippocampus, you would lose your ability to be able to have episodic memories, but you might still have your semantic memory. So the semantic memory is those, let's say, pieces of facts that are extracted over a time from our episodic memories that we are making over time. But those facts could also be there for a longer period of time if we even have some kind of, let's say, deficits in hippocampus. And for example, those who are experiencing, let's say, Alzheimer, sometimes when they have challenges with their hippocampus, they may lose their specific memories, their episodic memories, but sometimes they still have their, let's say, conceptual semantic memories that are there and are playing a significant role. Just to give you kind of few other pieces of that story of mental representation, semantic memory, and how they are being encoded in the cortex, I can just give you another kind of few examples. As you can see here, when we learn an event, then here we have a specific episode of a specific, let's say, learning process. You learn different pieces. They would represent it in neocortex first, from neocortex. But neocortex, I mean whatever we have in the, let's say, gray matter in the cortex. They would be represented in MTL, or medial temporal lobe, which is basically all the complex that we have after the inferior temporal gyrus within the kind of the inner part of the temporal cortex that we have. We call kind of medial temporal lobe. That includes hippocampus. So medial temporal lobe includes hippocampus, and we discussed about those other pieces that we have in medial temporal lobe. We know that we have parahippocampal gyri. We know that we have entorhinal and rhinal cortices. So we have some other kind of components there as well. But they would be represented in neocortex. They would be represented then in MTL, and these maps are going to get connected. But first of all, they would be connected well in MTL. So A, B, C, they are connected here. When we do memories again and again and again, they could also get connected in the cortical level as well. So over the time, we might have the connection in the cortical level as well. So if I go back to the figure that I showed you before, in terms of, okay, these pieces in the neocortical part are not connected to each other, it is true, not forever. But if we experience this again and again, over the time, they could also get connected in the cortical level as well. So we know that these cortical connections could be happening, but not with the first exposures. It takes a longer time to be able to have connections in the cortical level, okay? And then, when we start to remember things, we start with a specific cue. That cue activates the map in the middle temporal lobe, and then the map would activate what we have in the cortex. So that is the way that we have. If we have these things well connected to each other, if they are well connected, even without MTL, when we have the activation of B, then we will have the activation of ABCD. So that is the reason that when we have an injury to middle temporal lobe, those memories that are well connected and well experienced and well, let's say, conceptually processed, they could still remain there. But we lose memories that are mainly episodic, related to specific autobiographies. They are not very much related to, let's say, the concepts and facts. They would be gone when we lose to have hippocampus within the MTL. And how these, let's say, consolidation and storage would be happening in the neocortex and hippocampus is something really complex. So there are specific cellular mechanisms for that. Just to have some, let's say, specific names in your brain, we have two major cellular mechanisms. One is called LTP, and the other is LTD. And LTP is related to neurons that mainly are glutamatergic, and LTD is mainly related to neurons that are GABAergic. And you know GABA is negative, inhibitory, glutamate is excitatory. And long-term potentiation, it means that in the synaptic level, when we have a specific action potential, here is our synapses. When we have an increase in long-term potentiation, it means that the lower, let's say, the lower amount of current in the presynaptic pathway would still be able to activate the postsynaptic pathway. So let's say before we needed to have something like 10, something like arbitrary unit of activation here to be able to make an activation here to just pass the synaptic level. But after long-term potentiation, even with something like 2, we can still have activation on the postsynaptic level. So we know that long-term potentiation would be able to just kind of increase the synaptic kind of strengths here. And it is exactly then the opposite way for the GABAergic neurons that would decrease or increase the inhibitory role that they have in different levels of the brain. And there are many studies in terms of how these things are happening inside the brain. And I'm not going to discuss about that. Just to know that LTP and LTD are so well known that when we write grants for places like NIH, if you want to say LTP, LTD, you do not need to provide the details of these abbreviations. I mean, everybody knows what LTD and LTP. So, I mean, you do not need to provide the details. So that could be a good example in terms of how these things are being well known by people in the field and kind of the technical details that we have about these kind of issues. But how these consolidations would be happening in the brain, that is going to be something complex that we'll discuss about them later. Okay, so that was the second part of the class. So we tried to see what are the parts that are related to, let's say, memory representation in the brain and how hippocampus and cortex are related to each other, and how hippocampus would be related to episodic memories that are mainly autobiographical, and then how semantic memories that are mainly fact and concepts would be represented mainly in the neocortex, and how these maps are related to each other. And when we have a cue in the cortical level, when we have a specific cue in the outside environment that is going to be represented in a part of the cortex, then that cue would activate a map in the hippocampus, and then the map would activate the larger map on the neocortex, and the larger map on the neocortex would give us the full re-experience of that memory that we have in our brain. So that is the way that this system is being processed, or at least this is the way that we understand this system right now. And it might be changing over time, but that is an overview about how these systems are interacting. And it is well in line with the studies that we have with brain lesions. When we have a lesion in hippocampus, how that is going to be affected by this process.